Hi, I'm Henry Yim and I'm a 6th grade elementary school student. And today we will be learning how to derive the volume of a sphere using the integration method, which is a part of calculus. So let's do the math. So here's some general information you need to know. So here's a disk, and then in a real sphere it'll be really small. But we can put an infinite amount of these disks all stacked on top of each other. They'll all be different lengths. And then you can create the volume of the sphere. So here you can see I created a diagram of the Pythagorean theorem. And you can find one point on the you can find the hypotenuse, which will help you with the integration method later on. Okay, so let's start doing math. So volume, this represents a really small volume, delta volume. It will be equal to pi r squared h, that's the volume of a cylinder. And instead of r, it will be x. And then the h will be dy, because again, the delta represents a really small amount. Okay, so now we have our basic formula. So I'm going to show you something. So because we need to represent the x squared in the terms of y coordinates, we can write it as x squared equals to r squared minus y squared. These two are the same thing. So then we can start calculus, which means integrating. So volume equals to, and this would represent x squared, volume equals to 2 pi, and then here's the integral, because 2 pi is a constant in our deviation, times x squared times dy. Oh wait, and then in the integral, here's the minimum point and here's the maximum point. And the minimum point is 0, and then the maximum point is r, because I'm putting a 2 pi and a 0 and r because this only represents one hemisphere of the sphere, and then when you multiply it by 2, it'll be easier, so we don't have to do complex math at the end, so we can get the entire volume of the sphere. Okay, let's carry the equal sign down. Okay, and then we can substitute in what we got for x squared. So that'll be 2 pi integral r 0, and then big parentheses, r squared minus y squared. Then we can distribute it, now we'll also take the integration using y. R squared times y minus y cubed, add on the exponent, then you have to divide by 3 to balance it. Then you have r and 0. So then you're going to have to substitute r and 0 into this in two separate terms. So we can move out the 2 pi. So it's going to be It's going to be r cubed because you're substituting in r for y, and then r squared times r will be r cubed minus r cubed divided by 3 minus the second term will be 0, so that will be pretty easy because this whole term will become 0 minus 0 cubed divided by 3. So I guess you can just eliminate this because that would all become 0. So we're almost done. And then 2 pi. And then this becomes 3r cubed because you're multiplying by 3 to get rid of the denominator. For the common denominator. So 3r cubed minus r cubed is 2r cubed divided by 3. Okay, and then let's multiply. And there you have it. The volume of a sphere. The formula for the volume of a sphere. And that is using the integration method of calculus. And once again, you're using this disk method in the hemisphere. And then when you take out the 2 pi for the constant, it really helps you do this. So thank you for watching my video. I hope my step-by-step tutorial really helped you understand the concept for the volume of the sphere and the integration method. And thanks for listening. Bye!